in this problem we are given a peptide, primary structure of this peptide, and we are asked to determine the highest positive charge of an ion that would cause a peak in the electrospray ionization mass spectrum of that peptide. So in electrospray ionization mass spectrum, we have only positively charged, because this analysis is performed in formic acid solution, so everything will be protonated. So we have only positively charged ions to be detected by this mass spectrometer. And among the amino acid residues that can contribute to the positive charge, we have histidine with the side chain containing an imidazole group that can be protonated like that, right? Lysine with one letter code K that has an amino group that can be protonated, and arginine, abbreviated as R, which has a guanidino group that is protonated in aqueous solutions most of the time. In addition to those amino acid side chains, we have alpha amino group. The amino group for the N-terminus, right? That can be also protonated. So by counting this type of amino acids and including alpha amino group, we will know what is the highest positive charge that this peptide can get. So we have one histidine here, one lysine here, two, another lysine, three, third lysine, four, and we have arginine, 5, right? 1, 2, 3, 4, 5, plus alpha amino group. So we expect the highest positive charge to be 6 plus. Now, the next question is to pretty much sketch the spectrum, determine the number of peaks and the M to Z ratios for each peak. So in mass spectrum, the signal is characterized by M to Z value, which is the mass composed of the mass of the peptide plus a Z number of hydrogens, right, protons attached to that to protonated, divided by the charge, correct? Here, this mass is 1 gram per mole. So if we know the mass of the peptide, here, we can predict, calculate, the M to Z values for each of the expected peaks. And we know that we can estimate the weight of a peptide, usually longer peptide, based on the average molecular weight per amino acid residue. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So we have 22 amino acids. We multiply by 110 gram per mole per amino acid, and that gives us 2420 gram per mole, right? Or Dalton, as we call it for peptides. And so we will have 6 peaks. This is my M to Z. The lowest, and that's just intensity, right? The lowest peak will be the most protonated peak. So I have here 6 plus, and its M to Z value will be calculated as, so we also refer to that peak. Actually, let me use a different color, and I am going to just put it right here. So we refer to this peak as M plus 6H, 6 plus, something like that, right? Or just plus over there. And so we will use the mass of the peptide plus 6 over 6, which gives us 404.3. That's it, right? So here, this value, we expect to have 404.3. The next peak would have 5 protons, right? The charge of plus 5. And the value here will be 485. And we can go ahead and calculate the expected M to Z value for all those peaks. And then I'm going to sketch it. Right? So as a result, those peaks are going to be, at first they are close to each other, but the distance goes larger and larger and larger. And my last one, I need to continue here probably, and you don't see it. Sorry, it should be. Two plus, 1 plus. And I'm going to mark all those values right here. So this is our sketch of the electrospray ionization mass spectrum for that peptide.